Hey everyone, welcome back to the channel. Today's topic is super exciting. We're diving into how jet engines work. These powerful machines are what make modern flight possible, from massive airliners to high-speed fighter jets. Let's break it down in a simple way. 1. Overview of jet engines. Most jet-powered airplanes today use a turbofan design. You can think of it as a high-tech propeller inside a duct, called a diffuser, and it's driven by what's known as a gas generator. Let's start by understanding what's happening inside the core of this engine. 2. The core of a jet engine is where all the magic happens. It's basically a gas generator that creates high-pressure gases to power the turbine. Inside the core, we have three main sections: the compressor, the combustor, and the turbine. Let's explore each one. 3. The compressor squeezes the incoming air, making it denser, which leads to a much more powerful combustion reaction. Compression happens in multiple stages, where the air is forced into narrower and narrower chambers. Each stage has a spinning rotor and a stationary stator. The rotor blades spin and push the air forward, while the stator vanes slow the swirl, increasing the air pressure. In this example, there are 4 low-pressure and 10 high-pressure stages. That's a lot of compression power. 4. The combustor next. The compressed air enters the combustor, where it mixes with fuel and ignites. This process releases an extremely powerful jet of gas. This type of combustor is called an annular combustor, meaning it's ring-shaped. Each inlet nozzle has a fuel injector designed to swirl the fuel and air for an even mix. Then, igniter plugs, kind of like car spark plugs, light the mixture. Once the combustion starts, it keeps going as long as there's air and fuel. 5. The turbine. Now comes the turbine, located at the back of the engine. It's powered by the hot exhaust gases leaving the combustor. Part of this power turns the fan, and another part drives the compressor. Since turbine fins get extremely hot, some air from the compressor is used for cooling. Special coatings also help manage the heat. At the very end, the exhaust cone helps mix and accelerate the exhaust flow, giving that final push of thrust. 6. The fan. Early jet engines were called turbojets, where all the air passed through the core. But modern engines are turbofans, where only part of the air goes into the core. The rest, known as bypass air, goes around it. This makes the engine quieter and more fuel efficient. High bypass engines, used in commercial airliners, move large amounts of air at slower speeds, perfect for cruising. Low bypass engines, used in fighter jets, are smaller but deliver massive thrust and high speed, though they're louder and burn more fuel. 7. Afterburner. For fighter jets, some high-performance engines come with an afterburner. This system sprays extra fuel into the exhaust stream, igniting it for a second burst of power. It's great for takeoff, climbing, or combat maneuvers, but it uses a lot of fuel, so it's only used for short bursts. The exhaust nozzle adjusts automatically to control pressure and keep the engine safe during these power boosts. 8. Wrap-up. And that's how a jet engine works, from air intake to roaring thrust. It's an incredible mix of engineering, physics, and precision that keeps airplanes soaring through the sky. If you found this explanation helpful, don't forget to like, share, and subscribe for more awesome educational videos like this one.